horn-type bypass is a shunt connection utilized in standard wattmeters to minimize the current flowing through the voltage coil when measuring high power. The primary purpose of a horn-type bypass is to protect the voltage coil. When measuring high power, the current flowing through the voltage coil can exceed its rated capacity, potentially damaging the coil. The horn-type bypass provides an alternate path for a portion of the current to flow, thereby reducing the current through the voltage coil. A typical construction of a horn-type bypass consists of a conductor shaped like a horn, which is a tapered cone that is connected in parallel with the voltage coil. The conductor is typically made of a non-magnetic material, such as brass or copper. The working principle is as follows. As the power being measured increases, the current through the wattmeter also increases. This causes the magnetic field generated by the current coil to increase. The increased magnetic field induces a voltage in the horn-type bypass conductor. The induced voltage is proportional to the square of the current flowing through the wattmeter. As the current increases, the induced voltage also increases. This induced voltage opposes the voltage across the voltage coil, creating a bypass path for a portion of the current. Advantages include firstly, protecting the voltage coil from damage by limiting the current flowing through it, and secondly, improving the accuracy of the wattmeter, especially at high power levels. Disadvantages include firstly, slightly reducing the sensitivity of the wattmeter at low power levels, and secondly, potentially introducing some additional inductance into the circuit. Applications of horn-type bypasses are typically used in wattmeters designed for measuring high power levels, such as industrial power distribution systems, power generation facilities, and electric motors and generators.